Part of the ACS for the airplane instrument rating is DME Arcs. For your practical exam, you may or may not have to fly a DME Arc depending on whether one is available in your area. However, you will likely be asked to demonstrate your understanding of how to fly a DME Arc. This lesson will present all the information you need to understand DME Arcs and how to properly fly them in the airplane. What is a DME Arc? A DME Arc is part of an instrument approach procedure. A DME arc includes a constant radius arc around a navigation aid, commonly a VOR. That means the VOR is the center of the arc. The DME arc is a structured way to transition from the en route phase to the final approach that starts at the initial approach fix, or IAF, and the IAF will typically be a waypoint along the airway. This means that if you have been told to expect an approach that includes a DME arc, in the event that you lose communication with ATC prior to receiving clearance for the approach, you can transition from the en route phase to the final approach by joining the DME arc at the initial approach fix along the airway. The DME arc can include a descent as the arc is traveled, or the altitude can remain constant. Here is a DME arc scenario. You are traveling in IMC from San Diego to Phoenix on Victor 66, but before Yuma, you determine that you need to land at Yuma, KNYL. You've been told to expect the ILS 21 right, but after that, you lose communication with ATC. How will you transition to the ILS final approach course? Let's look at the ILS 21 right approach point into KNYL. First, let's see if we can determine why a DME arc is needed. Look at the final approach course. You will notice that there is a restricted area to the northeast of the final approach course. In this situation, the DME arc allows traffic coming from the north or the west to join the final approach course at Mudgee. For this scenario, we are heading from the west, heading to the BZA VOR. What direction will we turn to join the arc? Our initial turn is a left turn. What direction will we be turning to fly the arc? We will be making right turns around the arc. How will we visualize the DME arc? For that, let's look at our OBS. To visualize the DME arc, the center of your OBS is the nav aid, typically the VOR. The next step is to determine if you are flying to or from the nav aid. Then determine the direction of your initial turn, in this case left. Then, identify the direction of the turns around the arc, in this case right. Note that the radials of the OBS match the radials that we cross on the approach plate. For this example, look at the center of the OBS as our VOR. We are flying to the VOR, entering on the 180 radial. At the initial approach fix, our initial turn is left. Then we will make right turns around the arc. Notice that the radials we cross match the radials on the OBS. Now our arc matches the OBS. Let's try another one. In this example, are we heading to or away from the nav aid? We are heading to the VOR, so we see a to indication on the OBS, and we will make a left turn to join the DME arc. Then we will make right turns around the arc. We will cross these radials along the arc. This example shows the challenge of visualizing the DME arc on an OBS because the direction does not align with the OBS. But what if we rotate the OBS to match our flight path? Now you can more clearly see that the radials we cross match the arc around the bottom of the OBS. Now that we know what it looks like, we need to know how to fly it. When we are heading to the nav aid, the radials to intercept will be on the bottom of the OBS. The direction of the initial turn will show you the side of the OBS on which the arc is located. Before the initial turn, twist the OBS 10 degrees. The heading to turn to is 90 degrees from the new radial. After the initial turn, your next turns are right turns to fly the arc. As you travel around the arc, twist the OBS to move the new radial to the bottom of the OBS. For the final turn to intercept the inbound course, you will turn the OBS to the direction of the VOR on the final inbound course. When we are heading from the nav aid, the radials to intercept will be on the top of the OBS. The direction of the initial turn will show you the side of the OBS on which the arc is located. Then, twist the OBS to move the new radial to the top of the OBS. Then, your heading to turn to is 90 degrees from the new radial. After the initial turn, your next turns are right turns to fly the arc. For the final turn to intercept the inbound course, you will turn the OBS to the direction to the VOR on the final inbound course. Here are some additional tips for flying the DME Arc. 1. Lead the initial turn by 0.5 nautical miles for every 100 knots of airspeed. Divide your airspeed by 100, then take 1/2 of that number. For example, if your indicated airspeed is 180 knots, divide by 100, which is 1.8. 1/2 of 1.8 is 0.9 nautical miles. Second, for the initial turn, twist 10 degrees on the OBS to identify the new heading, 90 degrees from your OBS heading. Third, then start the standard rate turn to that heading. 4. When the needle centers, turn 10 degrees first, then twist 10 degrees on the OBS. 5th, these steps will repeat as you travel around the arc until 10 degrees before the inbound or final heading. 6th, as you travel around the arc, you may need to make corrections to maintain the required distance. If the distance on your DME is greater than what is desired, then turn 15 degrees to tighten the arc. If, on the other hand, the distance on your DME is less than what is desired, then only turn 5 degrees to expand the arc. Adjust this as necessary to maintain the desired radius. 7. The final turn to the inbound course can be anywhere from 0 degrees to 110 degrees, so prepare to twist the OBS to the inbound course. Now let's talk about wind correction. The relative wind will shift as you travel around the arc, depending on the number of radials crossed. Maintain a constant distance from the VOR, plus or minus 1 nautical mile. If the radius is decreasing due to your wind, you may need to continue your heading to cross the next radial instead of turning. If the radius is increasing due to wind, you may need to turn 20 or 30 degrees instead of 10 degrees, depending on how much the wind is affecting the radius. The key is to monitor your distance and make adjustments at the first indication of a change. We talk about turn 10 and twist 10, but look at this DME arc at Martin State Airport. The distance from the VOR is 14.7 nautical miles. When the distance from the VOR is more than 10 nautical miles, 5-degree turns will help maintain a better distance. This is because at this distance it will take longer to cross each radial. Therefore, you have time to fly the arc with smaller turn increments. With an HSI, flying the DME arc is different, but is actually easier to visualize. When flying a DME arc using an HSI, the center of the HSI is your airplane, and the representation of the CDI always has the heading at the top of the CDI. Recall that with a DME arc using an OBS, the center of the OBS was the VOR, and we looked for the radials that would be crossed to determine which part of the OBS to center as the airplane flew the arc. With an HSI, we will still cross radials, but our focus will be on the airplane's bearing to the VOR, which will always be at 90 degrees to the heading as we travel around the arc. Because the heading is always at the top of the HSI, your turn 10, twist 10 is a right or left turn in the direction to follow the arc. Then, twist the CDI 10 degrees in the same direction to maintain a 90-degree angle between the heading and the CDI. Then, the CDI representing the next radial to cross is visually displayed as the airplane, the center of the HSI, is driving to the radial. The final turn is either to or away from the VOR on the final course. Because the HSI always puts the heading at the top of the CDI, flying the DME Arc is much easier. Here are some additional notes about a DME Arc. You should never be surprised to receive a DME Arc. In your pre-flight planning, you should know when a DME Arc is included in one of the approach plates at your destination. Even in our situation, where we had to land at KNYL unexpectedly, pulling up the approach plates to KNYL would have indicated the possibility of the DME Arc for the ILS approach on runway 21. Right. Another note, you may receive vectors to final. In many approaches, the final approach fix is within the minimum vectoring altitude, or MVA, where ATC can vector you to the final approach fix. Even though there's a DME Arc plotted on the instrument approach procedure, you may not be assigned to fly the Arc. Another note, DME Arcs are used with ground-based navigational systems, like VORs. As more ground-based navigational aids are decommissioned, the number of DME Arcs will similarly decrease. That is why most of the DME Arcs today are based on a VOR compared to an NDB or ADF. However, just because you see an arc on an instrument approach procedure, it may not be a DME arc. This example from Palomar Airport in San Diego shows an arc that is flown with GPS waypoints, but is not tied to a ground-based navigational aid. In this approach, the GPS is relied upon to give turn instructions to maintain the desired radius. Want more DME arcs? Look at these examples and take the time to work through each of the 5 questions. Look at the VOR runway 30 with a DME arc at Jacqueline Cochran Regional Airport. It is a short arc, but notice that it is 13 nautical miles from the thermal VOR. Press pause and answer the 5 questions. Okay, let's work through this. The mountains surrounding the Jacqueline Cochran Regional Airport are likely driving the need for the DME Arc. But also remember that mountains can interfere with ATC coverage, which means ATC may not be able to provide vectors to the final approach course. Did you assign yourself a starting location on the approach plate? If you look at the approach plate, the entry from the airway will be at the thermal VOR, then heading eastbound to the initial approach fix on the 109 radial at 3,900 feet. If you join the arc at the IAF, you will make a right turn to join the arc and then right turns to follow the arc. Were you able to visualize the arc? Now let's look at the VOR Alpha with the DME Arc into Ogden-Hinckley Airport. In this example, you can see that there are mountains on both sides of the airport limiting straight-in approaches. Press pause to work through the questions and imagine yourself entering on the airway either from the north or the south. Okay, where you are on the approach plate will determine the direction of your initial turn. That will also determine whether you're making left or right turns. Regardless, can you visualize yourself on the OBS with the direction of turn and the radials that you will intercept? For our last example, let's look at the VOR Alpha with the DME Arc at Watsonville Municipal Airport. This DME Arc is different from our other arcs in that our final turn is away from the VOR. That means we will be crossing radials and then turning out from the VOR to intercept the radial with a from indication. Press pause here to work through the questions and visualize yourself on the approach as well as the OBS indication. I hope this DME Arc lesson has helped you. I worked extensively with a VOR simulator that had both a VOR and HSI, so I could visualize both the movement of the airplane and the representation on the OBS and the HSI. I would encourage you to find a VOR simulator and run through the examples in this lesson. I guarantee you will be a lot more confident about flying a DME Arc after you do that. Thank you for watching.